So about this project, this is a 508-kilometer long project from Mumbai to Ahmedabad with 12 stations along the western coastline. So it was sanctioned in December 2015 by an empowered committee of the Government of India. Its length is about 508 kilometers, standard gauge. Initial cost was 980 billion rupees, but that was when we had we had planned to keep it on ground at grade, but later on it was decided for safety reasons to take the entire stretch on viaduct except for the tunnel portion, the last portion from Thane to Mumbai, which would be about 21 kilometers. So the cost has slightly increased to 1080 billion. And it is funded by a Japanese loan, 81% of it. And as I told you earlier, the speed is 320 kmph. And it would take, there would be two kinds of trains running in the stretch. The ones with limited stops would take about 2 hours, and the other one, which would stop at all the 12 stations, would take 3 hours. And if you compare it with the present train, Shatabdi takes more than between 6 to 7 hours, and other trains normally take more than 8 hours. So mostly elevated, 450 kilometers, and the longest tunnel is the 21-kilometer tunnel from Thane to Mumbai, out of which 7 is under the sea. And there are other small tunnels between the end of Gujarat to when we enter Maharashtra, and the total length is about 5 kilometers. These are very small, short length tunnels. 12 stations, and all of them on viaduct except Mumbai, which would be underground at BKC. Power supply would be 2 into 25, similar to DFC, although the OHE would be different. The conductor sizes and the tensions would be different. So it will be a heavy compound catenary, unlike the other OHE system, which is a simple catenary all over India as well as DFC. Signaling will be digital Shinkansen ATC, which is specific to Japan. Basically, cab signaling, communication base, no signal post, with primarily train detection by track circuit and secondary detection by axle counters. And then we have a backup on radio communication. And there will be two major maintenance depots, one at Sabarmati, which would be the workshop as well as the shed. So this will be the bigger one. And the smaller one, only the shed at Thane. And the control center would be at Sabarmati. This is important because there are no signals. This is a communication-based signaling. And the training institute, which is already being constructed, it would be at Vadodara. And this is in the same campus as the Railway Staff College, earlier known as Railway Staff College. And this National High Speed has been incorporated by the government to execute this project. So the project was sanctioned in December 15th, and in February 16th, NHSRCL was incorporated. So now we have completed 2 years, and we are around more than 100 now employees in this company. And this is jointly owned by the Government of India as well as both the states. And we have a corporate office in Delhi, in Dwarka, and we have CPM offices in Ahmedabad, Vadodara, Surat, and Mumbai. Surat is, it has been designated, but it is yet to be operated. There are very few officers posted, but other 3 are fully functional. And Surat is likely to be fully functional by end of this month. And this one slide just to say and explain how this is different from other projects and the high priority which the government has given to this project. All the railway projects, including DFC and other projects being executed by RVNL, they are also the metro projects, they are all monitored by one ministry or one state or the Ministry of Urban Development or Ministry of Railways. But here, at all levels, this is jointly being monitored and coordinated by both the governments. So at the apex level, we have from Japanese side a special advisor to PM of Japan, and from Indian side, Vice Chairman Niti Aayog. And this apex level meeting is done every 3 months. So you can see how high the priority government has given to this project. And working group is normally chaired by CRB, Chairman Railway Board, and Ambassador of Japan to India, and all the related ministry, including External Affairs and Department of Economic Affairs, which is coordinating the loan, all of them attend all those meetings. And for technical meetings, which are done at our level, NHSRCL is the coordinator, and all those meetings are attended by the Ministry of Land Infrastructure and Transport from Japan, JICA, which is the funding agency, Embassy of Japan, as well as the Japanese Railway East, which is the operator nominated by the Japanese government for this project. And JICC is an offshoot of JRE. They are the consultant, the general consultant, as well as the PMC for this project. Few slides quickly on the status, because a lot of the participants, some of them have asked me that how is it going. So this was the news, the groundbreaking in September last year. And the GC and this PMC have both been appointed, which is the Japanese consultant, JICC. And social impact land consultant all have been appointed, and a lot of work have been done now after their appointment. Technical standards for all the packages, that is civil, track, rolling stock, power supply, signaling, all have been finalized. Schedule of dimensions have been finalized and accepted by NHSRC. All the horizontal alignment have been completed, and center line has been marked in about 340 kilometers. Few stretch in Palghar district is balanced, and then tunnel area, this is not required. And most of the survey, the LIDAR, first time we have done the LIDAR survey, which is using laser and helicopters. We have surveyed the full stretch. DGPS, all that has been completed. Geotechnical also, including the tunnel area, has been completed. So designs are being made based on these results of these investigations. LA plans have been finalized, and all the LA plans have been submitted to the 12 districts involved, and land acquisition is in various stages of progress. So power supply is, there are about 14 traction substations, 12 on the main line, so that is every 50 kilometers, and one each for the depot and the workshop. And these distribution substation, DSS, are for the stations and also for the depot, and there are some pumping substation required for the tunnel area. So all these simulations and studies have been completed, and power requirement has been worked out, and we have also got the letter from the Ministry of Railways to treat NHSRCL as a railway administration under the Railway Act. So we have gone in as a distribution licensee, and we have applied for connectivity in Gujarat as well as Maharashtra. And there also the surveys have been completed, so power supply works are in quite an advanced stage. Unlike other metro and railway projects where we wait for the contractor to come and then he does the simulation study and then the power requirement is worked out, that takes about that full process takes 1.5 to 2 years. That has already been done here. So, So this is a slide to summarize the power requirement for this project. So you can see the traction power requirement, 2 years have been shown. First is the commissioning year, which is 2022, and then the final where we need the peak traffic has been planned. So you can see the power requirement is substantial for traction as well as the distribution substations. The Mumbai station and the Sabarmati depot have a substantial auxiliary load, and the rest of them are on the similar range, the station side. In terms of energy efficiency, high speed the study has been done by UIC, and it is the most energy efficient means of transport if you take passenger kilometers carried per unit of energy. And since the competitive mode of transport is by air, you can see it is about 8 times better than air in terms of energy efficiency. And in emissions, it is also four times better than the competitive air transport.